Oh, hey, I didn't see you there. I was just about to get started with our pre-algebra lesson. Today's topic, systems of equations, word problems. Print out the PowerPoint, work the problems with me. All right, let's get started. It's Virtual Math with Mr. Ferrara. Hey, what's up everybody? Today we're going to be doing word problems that involve systems of equations. Just a couple strategies before we get started. Strategy number one, I recommend that you underline or highlight any of the important information. Read through the word problem and look for numbers and words that are going to help us solve the problem. Two, I recommend that you define your variables. What I mean by that is if a problem is talking about cats and dogs, maybe instead of using X and Y, you use C for cats and D for dogs. If a problem is talking about markers and pens, maybe you use M for markers and P for pens. Pens just happens to be our mystery word number one. Pens, P-E-N-S. Strategy 3, there'll be two equations to set up. Make sure that you enter the correct information for each equation.
All right, let's take a look at some examples for word problems. Example 1 says, a farm has a total of 15 horses and chickens living in a barn. There are 44 legs in that barn. How many horses and chickens are there at the farm? When we do word problems, there's always two situations that we need to relate together. In this case, there are animals in the barn and there are legs in the barn. I need to write an equation that relates the legs in the barn. Then I need to write an equation that relates the animals in the barn. So let's talk about the animals first. There's a total of 15 horses and chickens. I could write that as an equation. I could say there's horses plus there's chickens for a total of 15 animals. Horses plus chickens equals 15. Now each of those animals has legs. Let's assume it's a standard horse that has 4 legs and a standard chicken that has 2 legs. I can also write an equation relating those two things. I know that horses have 4 legs. I know that chickens have 2 legs. And the total of this equation is going to be how many legs there are in the barn. So there are 44 legs in the barn. Those two equations can now be solved using systems of equations, elimination, to find out how many horses and chickens there are. So I'm going to eliminate the H. Positive 4 down here means I need to cancel that with a negative 4. So I need to multiply this equation by negative 4 in order for that H to turn into a negative 4. So I distribute negative 4H. Negative 4 times C is negative 4C. And negative 4 times 15 is negative 60. This equation, the second one, had nothing happen to it, so I rewrite it. 4H plus 2C equals 44. And I now combine my equations. I add them up. Negative 4H and 4H go away. Just like in elimination, if one does not cancel, retry it. Negative 4C plus 2C is negative 2C. And negative 60 plus 44 is negative 16. I'm now at a one-step equation, so I divide by negative 2, divide by negative 2, and I find out that C equals negative divided by negative is a positive, and 16 divided by 2 is 8. That means there are 8 chickens in the barn. Well, if I know there are 8 chickens, I need to solve for horses. So I'm going to go to the top equation. That's the easy one. H plus C equals 15. I know that chickens is 8. H plus 8 equals 15. Well, what number plus 8 equals 15? Let's subtract 8. And we find out that H equals 15 minus 8 is 7. That 7 means there are 7 horses in the barn. So the answer to this question, how many animals were in the barn? 15 of them. 7 were horses, 8 were chickens. All right, let's move on to example 2. Example 2 says Reagan spends $131 on shirts. She buys fancy shirts for $28 and she buys plain shirts for $15. If she bought a total of 7 shirts, how many of each kind did she buy? Well, there's 2 situations. She's spending money and she's buying shirts. Let's start with the buying shirts. There are 2 types of shirts. There are fancy shirts and there are plain shirts. There are fancy shirts and there are plain shirts. And I know that the total amount that she bought of all of those shirts was 7. There's my first equation. I now know that she also spent money on each of those shirts. Fancy shirts are $28. Plain shirts are $15. And the money, this equation is dealing with money. The amount of money that she spent was $131. There are the 2 equations that we need to now solve. Well, this again is set up for elimination. So I'm going to get rid of F for fancy. Positive 28 cancels with a negative 28. So I need this equation to be a negative 28 up top. I do that by multiplying. Negative 28 times F is negative 28F. Negative 28 times P is negative 28P. And negative 28 times 7 is negative 196. This bottom equation had nothing happen to it, so I rewrite it. 28F plus 15P equals 131. I'm now going to eliminate my negative 28 and positive 28, and I add up the rest. Negative 28 plus 15 is negative 13P, and negative 196 plus 131 is negative 65. I have a one-step equation. I divide by negative 13, divide by negative 13, which means P, plain shirts, equals 65 divided by 13 is 5. Just a heads up, you'll never get negative numbers on these word problems. You can't buy negative 5 fancy shirts, or plain shirts in this case. So the number P equals 5 means Reagan bought 5 plain shirts. But she also bought fancy shirts, so we need to figure out how many that is. I know the equation F plus P equals 7 from up here, and I'm going to use that one. That's definitely the easier of the 2. 5 plain means fancy plus 5 equals 7. What number plus 5 equals 7? Subtract 5. We find out that F equals 7 minus 5, or 2. That means she bought 2 plain shirts. 2 plus 5 is 7. And if you did the math on the money, you'd find out that she spent $131. Our example 3. Example 3 deals with kids on a bus and van. A class of 195 students went on a field trip and took 7 total vehicles, buses and cars. Find the number of cars and the number of buses they took if a car holds 5 students and a bus holds 45. 2 situations going on in this problem. We got vehicles on this school trip, and we have students on the school trip. Let's talk about the vehicles on the school trip first. There are 7 total vehicles. Some of them are cars, some of them are buses. So I know cars plus buses is a total of 7 vehicles. There are also kids going on this trip, students. How many fit in a car? Well, if you look, there are 5 in the car. There are 45 in the bus, and the total amount of students, this equation is dealing with students, the total amount of students that goes on the trip is 195. We now have our 2 equations that we're going to solve. Vehicles on the trip, students on the trip. This is a positive 5. In order to cancel with a positive 5, I need this equation to be a negative 5. So I'm going to multiply this equation by negative 5. Distribute all 3 terms. Negative 5c minus 5b equals negative 35. Nothing happened to this bottom equation, so we bring it down. 5c plus 45b equals 195. I'm now going to add my two equations together. One variable should eliminate. My c's do. Negative 5b plus 45b is 40b. And negative 35 plus 195 is 160. You will not get any decimals for these types of word problems. You can't have a fraction of a bus. You can't have a decimal of a car. Divide by 40. Divide by 40. B is 160 divided by 40, which is 4. That means there are 4 buses on this trip. If there are 4 buses, we need to now find out how many cars there were. Going to go back to that top equation. That's the easier one. C plus B equals 7. 4 buses means that's cars plus 4 equals 7. Subtract 4. You find out that C equals 3. That C stood for cars, so there are 3 cars on this trip. 4 buses, 3 cars. All right, we have 2 more examples. Example 4 is a little bit easier of an example. Find the value of the 2 numbers if their sum is 12 and their difference is 4. Short word problem, easy to set up. Sum means to add, difference means to subtract. Now you can sit and guess and check and try and figure out the numbers on your own, but there is a system of equations that we can use to solve this. 2 numbers, I'm just going to call them x and y. You could call them any variables you want. I'm going to call them x and y. 2 numbers add up. Their sum is 12. Their difference means subtract, so x minus y equals 4. This does not have to have anything multiplied to it because positive y and negative y immediately cancel. A little bit easier of a problem. X plus x is 2x. 12 plus 4 is 16. Divide by 2. We find out that one number, 16 divided by 2, is 8. So one of our numbers is 8. We need to figure out what the other number is. So I'm going to use my x plus y equals 12 equation. X is 8. 8 plus something equals 12. I'll subtract 8. You get y equals 12 minus 8 is 4. Does 8 plus 4 equal 12? Yes. Does 8 minus 4 equal 4? Yes. So my big number is 8, and my small number is 4. There are your 2 numbers that add up to be 12 and subtract to be 4. And the last one is definitely the most complicated problem because there's a lot going on here. On Fridays, the admission fee at a small fair is $1.50 for children and $4 for adults, and they collected $5,050 on that Friday night. On Saturday, the same amount of people attended the fair. It cost $2.50 for children and $5.50 for adults, and they collected $7,600 that night. How many children and how many adults attended the fair? Well, let's break this down. There's a Friday equation, and there's going to be a Saturday equation. The Friday equation is $1.50 for children. It's $1.50 for children, and $4 for adults. $1.50 for children, $4 for adults. And a total amount of money on Friday night was $5,050. That's my Friday night equation. My Saturday night equation was $2.50 for children, $5.50 for adults, and they collected a total of $7,600. So again, we have a Friday night equation, we have a Saturday night equation, and we're going to solve this equation. Now this one's pretty tricky because the $1.50 and the $2.50, they don't have anything that they can multiply with easily and cancel. So what I'm going to do is I'm going to multiply this top equation by this number, 2.5, $2.50. I'm then going to multiply this bottom equation by the $1.50. So I'm just going to swap the numbers here, and that will make these 2 numbers cancel with these 2 numbers. The only difference is this one needs to be a negative. Now let's multiply this out. $2.50 times $1.50 is 3.75C. $2.50 times $4, again I'm multiplying, is 10A. And then 250 times 5,050 is 12,625. Big equation. I'm now going to multiply this $1.50 negative times 250. That gives me negative 3.75C. Negative $1.50 times 550 is negative 8.25A. And negative $1.50 times 7,600 is negative 11,400. I'm now going to add up these equations. And when I did this method, when I multiplied this number times this one and this times this, I got opposites which cancel with each other. $10 added to negative 825 is 1.75A, and 12,625 plus negative 11,400 is 1,225. I divide by 1.75. Divide by 1.75, I find out that A, adults, is 700. There were 700 adults at this fair. I now pick the equation, and I'm going to pick the first one. 1.50C plus 4.00, but instead of A, I know A is 700, and that equals 5,050. 1.50C plus $4 times 700 is 2,800 equals 5,050. I'm at a two-step equation. Subtract 2,800. We find out that 1.50C equals 2,250. Divide by 1.5. We find out that C equals 2,250 divided by 1.5 is 1,500. There were 1,500 children at the fair, and there were 700 adults at the fair. If you have any questions on today's assignment, please feel free to Schoology message me, email me, call the Google helpline, or ask your questions during our next live conference. Till next time, bye.